Good morning, Tal. This is Dick Riley, calling from Ophir Spiricon. I thought I'd try a little different approach to provide some training on this camera. I'd like to send it out today. I'm going to be in a meeting in Utah next week, which means I wouldn't be able to get it out until the following week, and I don't want to hold up your test plans. I have the SP928 1550 phosphor camera. You'll see it's quite a small, compact camera. It's 5x7mm array. You'll see that it has a red attenuator on it. This is an ND1 attenuator. USB 3 works for on USB 2 or 3 fittings on your computer. And I wanted to go through a quick setup program here using this video approach. I'm going to send over to you a Word document that's got a variety of pictures on it, all numbered, and if you can follow through on those documents as I discuss them, I think it'll make your job easier getting the camera operational and answering some of the questions you might normally have. If you look at that document on position number 1, this is the icon that you're going to see once you load BeamGauge software. You'll need to get that from our website. I'll send you the link. You'll likely need to sign in. There's no cost to it or anything of that nature. And download it. You want to get BeamGauge Pro. There's a standard and a Pro. You want to get the Pro version. And get that properly installed. And this is the icon you're going to see on your desktop. Once you open the program, it'll take it takes a little bit. It's a pretty heavy program, so it'll take 15, 20, 30 seconds to properly load. And more than likely, what's going to happen if you look at graphic 2 is you're going to see this image with the local detector on the left-hand side. You're probably going to see a gray screen on the right-hand side, which means it doesn't see the camera. So if you click on local detector, there's a small little arrow there. More than likely, what's going to happen is another little window will open right beneath that, showing you the serial number of the camera. Click on that and it will open. If it doesn't, go to your start button, go to Spiricon camera drivers, SP928, and just be sure the drivers have been installed properly, and go back and retry it. If not, unplug and replug the camera back in and it should come right back up, showing you this icon, and you can open the program from there. If you can't or it won't, obviously you'll let us know. Number 3, once the camera opens, you're going to see a screen like this on the right hand side, which is probably gray and purple pattern. And if you look in the down in the bottom right hand side of the home screen, you'll see the frame button moving along from left to right. This also is an indicator that the camera is operational. First thing we want to do is on graphic number 4, under the sensor source button is over to the right. You'll see a exposure, gain, and dark level slide bars. And what we're going to do is we're going to set the camera up to be as sensitive as possible, and by doing that we can begin to see a beam at under the lowest power possible. So what we want to do is we want to move the exposure button all the way to the right. We'll leave the gain and the dark level all the way to the left. Number 6, the next thing we're going to do under, again, the source button is you'll see a gold star. That's our UltraCal, the background subtraction program. You want to click on that, and this will baseline the camera to a nice purple and gray pattern. One of the things I found, and when I open up this camera directly on my laptop, if this attenuator is not in place, the camera saturates, and not unlike the graphic you see on 7B. This is going to tell us that if we need to use that camera without that attenuator on it to get as close as possible to the array, then one or two things are going to happen. We're either going to have to use turn off all the lights in the room, or get a dark cloth to shroud both the camera and the source to eliminate the possibility of any ambient light getting into the camera. Otherwise it will saturate. And that's what you're seeing with 7B. So assuming we can properly shroud the camera and keep out ambient light, and once we've done the UltraCal under 7C graphic, you should see a nice gray and black pattern on the on your display for the BeamGauge. Also, just as, again, reconfirmation that the UltraCal is operating properly, if you look at graphic 8, there's a little slide bar down the left-hand side of the screen, and this is an indicator that the UltraCal is operating properly. And once completed, you get this nice purple and gray pattern, which indicates we've got a nice baseline image. Number 10, under Beam Display tab across the top, we want to go over to the cursor section, and I'd suggest that you select the cursor to be on the centroid. This will put the crosshairs in graphic 11 on the center of the beam automatically. There's a manual and there's none as well, but typically to locate the beam easily, I typically will put the cursor on automatic centroid location. Number 12, this is just a setup issue. In the numerical box on the left hand side, you'll see there's a small icon there just to the left of the word partition. If you click on that, you get another window which is 13, and that allows you to increase the font size of all the numericals, making it just that more easily readable. Excuse me. Number 14, under aperture. Under the aperture tab, on the left hand side you'll see none. What we want to do is we want to put an artificial aperture around the beam, and this helps to ensure we're calculating only that information that's inside the circle, and also gives us a better indication as to how to set the power for the camera, and that will give us the power density values as well. So under the aperture tab, left hand side, go over to none. If you click on that, you get a variety of kinds of graphics you can click on. Generally I click on a circle, and if you look at 15 graphic, you'll see this circular graphic shows up in the upper left hand corner of the beam gauge screen. If you click on the circle, you'll see in number 16 you can grab that and drag it any place you want. You can also expand the size of it. Looking at number 17, what I've done is drag that over to the beam. I've expanded the aperture so it encompasses all of the beam, and it's out about 50% bigger than the beam itself. If you look at number 18, 18 is a selection of computations, and once we have the aperture set, we can then actually set the power. The beam has to be on the array at that point and inside the circle. And going up to computations under power and energy, we can select, we can change watts to milliwatts under, like as in 19. And by doing that, if you look at 20, we can click the check button, and you'll see that power and energy for the beam inside that circle now is described in milliwatts. You can't do this until the power of that beam is actually on the array. Otherwise, it assumes that ambient is power, and that's obviously not correct. If you look at number 21, 21 is helpful in being able to store information. You go to your start button up in the upper left hand corner, click on that. There'll be a drop down, and typically the only one you need to be concerned about is save data. You'll get a window like in number 22 that will allow you to save it wherever you choose. I would recommend in the bottom left hand corner of that window to save all the records. You can save one or two of the frames, whichever one you want, but typically I'll save all in the buffer, which is typically about 16 frames. Number 23 and 24, these are the last two. If divergence is an issue that you want to be able to calculate, divergence is done under the computations tab on the ribbon on the top, under the divergence section of computations, and we typically use the focal length method. So if you click on that, you'll see there's a 2-point method, and there's a third as well, but typically the focus length is the method we use. You can also change degrees to radians, whichever is easiest for you, and the value you put into that window then is the exact distance between the source and the camera array, realizing that from the front of the camera to the array is 4.5 millimeters, so whatever that distance is from the face of the camera to your source, that total distance needs to be inputted into your into this window, and it will automatically calculate divergence in the numericals on the left-hand side of the beam gauge window. So the key thing to do when you're setting this beam up for the first time is, one, you don't want to go into saturation, and you want to stay a point where you can put all the power onto the array as possible. You want the aperture, the manual aperture to encompass the entire beam, and if you are saturating, and you're not using an attenuator, you may have to use an ND1. The camera also comes with an ND2, which is a black one. My concern is that it may restrict you from getting close enough to the array, which means the divergence of the beam will flood the array, in which case the information is not going to be meaningful. So let me know if this has been helpful. I'll send over these pages to you, and you can follow along with the video accordingly, just as a follow along and getting instructed on the camera. So talk to you soon.